Hello learners, I am Dr. Munish Kumar Bhardwaj from School of Engineering and Technology of IGNOU. In last lecture I discussed with you some of the concepts of repairing materials for miscellaneous defects. Today I will discuss with you various type of defects in construction. So let us begin with what are different type of defects in construction. So let's begin with first the leakage. Leaking terraces, tanks and bathrooms in several newly built buildings, including multi-storied ones, are proof of a poorly made concrete mix. Honeycombed concrete, because of segregation of aggregates from cement in the concrete and air voids due to excess water in the mix, is a familiar sight in buildings under construction. If a column or beam of concrete has honeycombs or voids in it, moisture, chemicals and salt penetrate the structure and corrode the reinforcing bars. Since rust occupies several times the original steel volume, the concrete gradually splits and weakens the whole structure. Because you know that on rusting, the volume of steel increases many times. 5% voids in concrete could reduce the strength of a structure by 30% and 10% of voids by 60%. So it is so detrimental. If voids are there, then there will be huge reduction of the strength of the structure. Since honeycombed concrete is generally superficially plastered over, it is not noticed till the reinforcement has corroded and the concrete has split, causing cracks. If minor cracks by honeycombing and voids not repaired properly, the disintegration would continue like cancer and result in a collapse of the structure. Now let us discuss about voids in concrete. Voids in concrete are caused mainly due to wrong blending of aggregate and sand, which has less fine particles. This causes lack of cohesion in the freshly made concrete and therefore it segregates during mixing, transporting and placing, and finally results in honeycombed structure. Another cause of honeycombed concrete is the tendency for the workers not to use vibrators to fully compact the concrete, because if the concrete is not fully compacted, then it will have voids. Besides causing loss of strength in concrete and leakage in the roof, because voids are there, then water can penetrate and of course then leakage problem will be there. Then this leakage may be in roofs, bathrooms and tanks. Then there is another problem also there, excessive fine sand. Excessive fine sand leads to general weakness in a concrete on account of the high water cement ratio which their use entails. A coarse sand gives a stronger concrete than the fine sand, for the former permits cement to fill in the interstices between the sand particles and thus bind them together. In order that the cement may exercise the maximum binding action, the sand should be coarse enough for cement and water to get through its pores and surround each particle of sand. Because if coarse sand we are using, then cement water paste can go into the pores easily and it will form a layer around the particles of the sand. On the other hand, absence of sufficient fine sand below 300 micron mesh sieve tends to give harsh working mixes, which is prone to segregation and to different local defects. So, this is the importance of the quantity of the fine sand, that neither it should be too much nor it should be too less. Now, let us see cracks due to several other factors. What are different causes of the cracks? One of the main cause of crack is the cooling and contraction which follows the evolution of heat due to hydration of cement due to setting of the concrete. Volume change and stresses due to shrinkage are independent of any external load or stress applied, because there may be changes when loads are there or stresses are being applied externally. But here we are talking when no load or no stress is applied and then volume changes are there and stresses are there due to shrinkage of concrete. Cracks may develop in a smaller section attached to a larger section due to differential expansion and contraction, because when different size sections are joined, then there may be a different amount of expansion and contraction in the two sections, and due to this there will be differential expansion and contraction. There is more possibility of cracking of fixed members means which are restrained, than those which are free to expand and contract. As simply supported beams reduce restraints on free expansion or contraction of the structure, so here the simply supported beam is free to move in comparison to the fixed beam. Then repeated expansion and contraction or alternate wetting and drying, which may result in gradual disintegration of poor concrete. Rapid drying due to hot weather and high winds or absorption of water from the concrete by wooden forms. The formwork on which fresh concrete is placed must be damped, or it should otherwise be waterproof so that it does not absorb water from the concrete. Ensure adequate moist curing of the concrete. Formwork should be of adequate strength to bear the pressure of wet concrete without swelling, spreading or any movement in it. Concentration of tensile reinforcements at square openings or re-entrant angles, as in corners of doors and window openings, causes cracks. Minute cracks on the tension side of a reinforced concrete member are unavoidable due to the poor tensile strength of concrete as compared to steel, and which must crack when the steel reinforcement takes its load. The flexural tensile strength is slightly higher in beams with a depth between 15 to 30 centimeters. However, it is better to neglect this in practical work. Concrete members crack if the tensile strain exceeds 0.01% to 0.012%. This rupture strain is almost independent of concrete strength. In numerous cases, it could be seen that the cracks occurred already during the first days after placing the concrete before any load acted on the concrete structure. They are caused by internal stresses, that is self-equilibrating stresses due to differential temperature, which are higher than the slowly developing tensile strength of the structure. These temperatures must mainly be traced to the heat of hydration, which the cement produces during the hardening period and which so far was usually neglected with the exception of massive structures. Depending on the type and the quantity of cement concrete members, 20 to 30 centimeter thick can warm up by about 20 degrees centigrade. 1 meter thick about 60 degrees centigrade during the first 2 days. So that is the how much heat is evolved, that you can see that in a member which is 20 to 30 centimeter thick, it can get heated up to 20 degrees centigrade, whereas 1 meter thick member can be heated up to 60 degrees centigrade. So lot of heat. If the heated member cools down too quickly by cold air mainly at night, then the stresses get easily higher than the still slow tensile strength and the concrete must crack. Even if only micro cracks form, they will reduce the final tensile strength of the hardened concrete. However, quite often wide cracks show up due to those defects even when much reinforcement was placed. Because a young concrete does not give sufficient bond strength so that it provides effective limit to the crack width. It is necessary to prevent such early cracks by keeping the rise in temperature so low that the resulting stresses remain smaller than the tensile strength. This can be reached by the following measures, either independently or in combination. The quantity of cement per cubic meter of concrete should be kept as low as possible by good mix design practice. The heat development can be slowed down by adding fly ash or using slag furnace cement. During curing, evaporation of water must be prevented at all open surfaces of the concrete structures by spraying a vapor barrier or by covering concrete with a dense membrane. Often, shrinkage is considered as a cause of early cracking. However, this is not true under normal climatic conditions. Shrinkage needs time in order to produce a shortening as high as the tensile rupture strain. Only in very hot and dry air, shrinkage can cause early crack in young concrete if the measures against evaporation are not taken. Now let's talk about the hair cracks. Hair cracks are partly due to the unequal shrinkage of surface concrete and mass behind it. Delayed finishing and final floating of concrete up to a certain limit avoids surface cracks. Surface cracks are also caused by surface dressing with a mortar too rich in cement, too much water, insufficient curing or from over troweling. These are the reasons for occurrence of surface cracks. Such hair cracks do not affect the strength of concrete. One way of avoiding such hair cracks is to remove the surface skin of the concrete by brushing it with a stiff brush soon after setting. Fine superficial cracking is known as crazing. Now we move to contraction of concrete. Contraction of concrete is more harmful than expansion as it sets up tensile stresses in the structure, particularly those with a large surface area and thus form cracks. Such contraction cracks may be prevented by inserting reinforcement near the surface. Closely spaced reinforcement of a small diameter and near the surface is more effective than large diameter bars further apart and farther from the surface. Contraction or shrinkage of concrete in hot dry areas is much greater than that in damp and cool climates. Then we move to causes of cracks after hardening of concrete. Cracks can develop by tensile stresses which are produced by restraining deformations caused by strains due to rising or falling temperatures or due to shrinkage and creep of the concrete. Imposed deformations like differential settlement between foundation can also cause cracks. Cracks in pre-stressed concrete bridges have taught us that they were mainly due to temperature differences produced by sunshine and following the cooling by rain or night. Now we move to size of cracks. Cracks are judged by the crack width at the surface of the concrete, which decreases towards deformed rebars. Long years of research and experience showed that crack width up to 0.4 mm does not significantly harm corrosion protection of reinforcing bars if the concrete cover is sufficiently thick and dense. Polluted air, especially carbon dioxide, causing carbonation, and sulfur dioxide forming acids or chlorides from de-icing salts damage the concrete independent of cracks. Structures must be protected against such attacks having cracks or no cracks. Cracks are harmful for the image of the engineers if they are easily visible because laymen consider them as a damage. Because one who is not well versed with the surface cracks, he will think that these are the structural damages. From the environmental criteria, allowable crack width can be as follows. Low aggressive environment 0.5 mm cracks are easily visible. Medium aggressive environment 0.4 mm, these are scarcely visible. Then high aggressive environment 0.3 mm for unarmed eye. So these are the criteria for allowable cracks in different environmental conditions. These values are valid for a normal concrete cover of 30 mm and bar diameter up to 25 mm. For a large cover, the allowable crack width can be increased suitably. Now let us move to causes of failure of foundations and remedial measures. Masonry should be raised uniformly over the whole area. A slow progress of masonry work makes stronger joints and has more uniform settlement. Now let us see unequal settlement of the subsoil, what it is and what it causes. Unequal distribution of the weight of the structure on the foundations due to eccentricity of loads causes unequal settlement. In continuous wall foundations, reinforcement should be provided whenever an abrupt change in magnitude of load or variation in ground support may occur. Then horizontal movement of the earth adjoining the structure. This is effective in the case of clay soils, black cotton soils. Such soils become soft and swell when wet, losing their bearing power considerably and shrink and crack when they dry. Now let us look at atmospheric action. Rain and the sun are the main agents for the atmospheric action with the change of seasons. Rise and fall of subsoil water level, increasing or decreasing the moisture content, which is especially effective when the underground water is near the surface, or in damp soils overlying a layer of porous material like sand, etc., causes cracks due to expansion or shrinkage of subsoil. Soakage of rainwater in subsoil also produces a number of changes as above, and sometimes bring in salts which react chemically on the lime and bricks in the foundations and cause them to disintegrate. Underground open drains should be provided to drain out the excess water when the subsoil water level rises. Deep foundations with sides well filled and consolidated with good slope away from the wall given to the ground surface will help against rains. A plinth protection of about 60 to 90 centimeter width with concrete or flat brick flooring will give further protection. Cement or hydraulic lime should be used with stone or overburnt bricks up to the plinth level in damp locations. It will help in checking the dampness of the element of the structure. Then we move next to the transpiration of trees and shrubs. This is a very important factor which is not generally considered. The drying effects of the transpiration of trees and shrubs are superimposed on the seasonal conditions mentioned above. Whenever the root system approaches the shallowly founded structures, the root systems of isolated trees generally spread to a radius greater than the height of the tree and have been observed to cause significant drying of fat clay soil to a depth of 3 meters. The fast going trees are especially dangerous, and within 5 or 6 years the root extend to a distance of 15 or 18 meter and dry out the clay abnormally below the foundation of the nearest part of the building. Sometimes a permanent depression of the ground is produced during the early period of the rapid growth when the tree demands more water than is available on the ground. Abnormal spells of dry weather have much more serious effects. It has been found that the differential shrinkage below the foundations can be sufficient to produce cracking in the brickwork. Such cracking can be most common at the western and southern side of the building, since these parts receive more radiation from the sun than the northern and eastern sides. The drying, which progresses from the outside towards the inside edge of the footing, causes outward tilting of the walls and corners, a movement which becomes magnified at top of the wall to 25 to 50 mm in the worst case. The outward movement of the wall may drag the upper floor and roof with it and cause cracking due to spread throughout the interior of the house. Trees growing close to a building on shrinkable soil may cause cracks in the wall. So that is a very big problem. So that what are the different causes of various defects in the buildings? I hope you must have enjoyed this discussion. So thank you.